Foundations of Amateur Radio. The hobby of amateur radio is one of experimentation and change. For decades, this came in the form of circuit diagrams, components and scrounged hardware from anything that wasn't bolted down. New functionality came with the aid of a soldering iron. More recently, functionality comes from participation in the global electronics market, where you can buy any radio you like and have it shipped to your door within hours at an unbeatable price. Mind you, buying all those unbelievably cheap radios does start adding up, and if you want to use more sophisticated hardware, that too is possible, at a price, somewhere between $50 and a new Porsche. Whilst that's an option for some, for the rest of us, there are better and cheaper ways. Of course, it doesn't stop there. If you connect any radio to a computer, you can use whatever software you like to encode and decode any signal you can imagine. With a traditional radio connected to a computer, you can make it participate in hundreds of different so-called digital modes. Before I continue, let's look at a radio in a slightly different way. Consider an antenna as a continuous source of voltages that are amplified, filtered and demodulated in some way by a radio. You can think of the combination of antenna, radio and computer as a stream decoder. To decode a signal in a new way requires a new decoder, which you could build from components or, as I've said, buy online. During the week I've continued experimenting with GNU Radio. If you're unfamiliar, it's a toolkit that allows you to build so-called flow graphs that can process a signal stream. Think of it as a box of Lego that you can put together to build any type of decoder. Let me say that again. Imagine that you want to decode or transmit a mode like FreeDV, M17, APRS, Olivia, Contestia or Hellschreiber. With the GNU Radio Toolkit, all of this is possible, and you won't need to buy new hardware or bust out the soldering iron every time you want to experiment with a new mode. If you have been playing with digital modes already, you'll likely point out that you can already do this today by using software running on a computer, and that's true. What that doesn't tell you is that this comes with a very specific limitation, namely that all those modes require that they fit inside a single audio channel, because all those digital modes you might be familiar with are essentially using an SSB or FM signal with the audio generated or decoded by a computer. Even if you have a modern radio like, for example, an ICOM IC7300, you'll still be limited in what modes of transmission you can make. ICOM limits the transmit bandwidth to 2.9 kHz. Flex radio appears to double that to 7.9 kHz, but numbers are sketchy. The point remains, most current amateur radio technology is based around the notion that a mode essentially fits within a single audio channel, and a very narrow one at that. So why does this matter? If you run out of FT8 space on a band, right now you need to change to an alternate frequency to play, but you'll only be able to see the stations that are using the same alternate frequency, as long as they fit within the bandwidth of an audio signal. If you wanted to check out the main frequency, you'd have to change frequencies and keep switching back and forth. Using this idea, monitoring all of FT4, FT8, Whisper and all CW beacons, all at the same time, becomes unimaginable, not to mention costly, if you needed a radio for each band and each mode. What if you wanted to use another mode that took more than about 4 kHz, like say a 5 MHz wide DVB-T signal, which you could be experimenting with on 70 centimeters? Or what if you'd like to compare a repeater input with its output at the same time? Or compare two repeaters together? Or find the best band to operate on right now? The point being that there are things that simply don't fit within a single audio channel that you won't be able to play with using a traditional radio. As it happens, that too is a solved problem. Remember that I mentioned that you can think of an antenna, radio and computer combination as a stream decoder? What if I told you that an SDR, a software-defined radio, is essentially a device that translates antenna voltages into numbers, which you can process with GNU Radio? Whilst that does imply replacing your radio, you don't have to jump in at the deep end to start playing, and even if you do decide to buy new hardware, you can get your toes wet with all manner of self-build or commercial kits. Even better, you can start with the gear you already have today and become familiar with GNU Radio. And when you're ready to expand your station, you can add in an SDR and continue to use the same tools to experiment. Not only that, you can do interesting things by combining what you already have. Consider, for example, the idea of using an RTL SDR as the receiver with a traditional radio as the transmitter. You could decode all of the FT8 signals on a band and transmit where there was space to do so. The point being that you can do this one step at a time. Every time you download or build another GNU radio flow graph, you can have a new decoder, and as time goes on, you'll be able to decide what hardware you might want to pair it with. To be clear, I'm talking about the gradual change from component-based radio using audio interfaces into software-based radio. It's not like we haven't done this before. Anyone recall spark gaps or valves? The future of experimentation is bright, and it's filled with bits. I'm Ono, Victor Kilo 6, Foxtrot Lima, Alpha Bravo.